College Algebra, Section 2.2, Graphs of Polynomials. Part 1, Introduction to Polynomials. A polynomial function is a function of this form, where we have f of x equals an x to the n plus a to the a sub n minus 1, x to the n minus 1, all the way down to a sub 0. Now, a sub 0, a sub 1, etc., these are all just real numbers, and n is a non-negative integer. So we have a polynomial means that we have a bunch of terms added together, where we have a coefficient and then an x to some power, where that power is just a positive integer or 0. It could just a non-negative 0. The domain of a polynomial function is all real numbers. So which of the following are polynomials? Let's figure this out. We have f of x equals 4x to the fourth plus 9 minus 13x squared. This one is a polynomial. What about this one, where we have in here a square root of x? That means it is not a polynomial. Square root of x is the same as x to the 1/2 power, and it says that our powers need to be non-negative integers. An integer is not 1/2. 1/2 is not an integer. So no, this one is not a polynomial. What about this one, where we have h of x equals 3x cubed minus 2 divided by x plus pi? This one is not a polynomial, and the thing that makes it not a polynomial is this term right here. So 1 over x is x to the negative first power, and again, we need the powers to be non-negative integers. This power is a negative integer, so this is not a polynomial. Let's suppose we have a polynomial function in that same form we had before. The degree of f is n, so the highest power of the variable that appears somewhere in that polynomial. So the degree is the highest power. The leading term is the term with the highest power. And the leading coefficient is the coefficient of the leading term. And then the constant term is the term that doesn't have the variable, so just a constant. And then given f of x equals a sub 0, as long as a sub 0 is not equal to 0, we're just going to say the degree of f is 0. If we have a polynomial f of x equals 5, so just some number, you could write that as f of x equals 5x to the 0 power. X to the 0 power is just 1, so we have 5 times 1, or 5. So we say the degree is 0. Find the degree, leading term, leading coefficient, and constant term of the following polynomial functions. So let's start with f of x. F of x equals 4x to the fifth plus 9x to the fourth minus 13x squared plus x minus 7. The degree would be the highest power. Now these terms are written in descending order of the powers, which is nice. So our degree is 5. That's our highest power. The leading term is that whole term, so 4x to the fifth. And the leading coefficient is 4. So that's the number in front of that x to the fifth. And then the constant term is negative 7. That's this part right here. For the next one, for g of x equals 2, the degree is 0. The leading term is just 2, and the leading coefficient is 2, and the constant term is 2. Let's find the degree, leading term, leading coefficient, and constant term of this polynomial that is not multiplied out. This one is factored. It's not quite as obvious what these are, but here's how we can find them. We could write this, the negative 3x, as negative 3x plus 0 to the first power. So our degree is our number that we'd get if we added all of the exponents together. If we were to expand all this, we'd end up with a term that has an x to the 6th power in it. 1 plus 3 plus 2 equals 6. So our degree is 6. Our leading term would be the first term of each of these factors raised to the power on that factor. So negative 3x to the first power, 2x to the third power, and x to the second power. So I multiply all those together, and we would get negative 24x to the 6th. So that is our leading term. And from there, we can see that the degree is 6, and the leading coefficient is negative 24. The constant term would be our polynomial if x is 0, what are we left with? So we have 0 times 3 cubed times negative 2 squared, which gives us 0 times 27 times 4, or 0. So that means if we were to expand all of this out, we would not have a constant term written. We'd have a plus 0, which we wouldn't need to write down. Let's actually look at the expansion, and we can see that this works. If we were to expand this whole polynomial, we'd have negative 3x times 2x plus 3 to the third power, so that one's written 3 times, and x minus 2 is squared, that one's written 2 times. And if we start our distributing and combining like terms and go through, we're going to keep distributing, combining like terms. It can be kind of a hassle to go through all this, but if we do this, we end up with h of x equals negative 24x to the 6th minus 12x to the 5th plus 174x to the 4th plus 135x to the 3rd minus 324x squared minus 324x plus 0. So we can see here's our leading term and here's our constant term, which is what we've decided before.